This is the review for 3.9. So this is our unit test for all things rational. Keep in mind, we did 90% of this unit led up to quiz 1. So you've got that quiz to look at, and then we've only had 2 new lessons between that quiz and this unit test. So most of you did pretty well on that quiz, so that's good. Keep that material in shape. This is what we have. So the big difference, everything we did in the first part of this unit was rational expressions. The last 2 lessons were solving rational equations. Make sure you know the difference. Okay, when you see an equal sign, you are looking for a solution. Know how to identify exclusions in rational expressions. Remember, anywhere that the denominator is 0 is an exclusion, and then those came in 2 separate varieties. You can look back at the review. It would either be a vertical asymptote or it would be a hole in the graph. Remember, when I'm writing an exclusion, I might write something like x cannot equal 2 or 3. If I'm writing a vertical asymptote, I might write that x equal 2 is the vertical asymptote, or if I had a hole in the graph, that might be written as x equal 3. Remember the difference, the exclusion, what x cannot be equal to. The asymptote in the hole in the graph shows you where x is for that occurrence. Knowing how to clear the denominator. This is in solving rational expressions, should be solving rational equations. And then the big thing, the reason we do exclusions is when you solve equations, you must go back and check those answers to make sure that you do not have an extraneous solution. So really the way to do that, if you have the exclusions up front, when you get a solution, if the solution matches the exclusion, it's not a solution. And then we also know that when you have something, an equation that's a fraction equal a fraction, you can do cross multiplying. It's the same thing as a common denominator. So let's take a look at this review. So the first one, I've got a rational equation that I need to solve. So we need to figure out what to do here. First of all, if you look at it, I can do one of 2 things. I can get the common denominator for everything. I can add the left side together. Let's look at factoring. That's one of the key things. Factor wherever you can. So this is 1 over x plus 5 plus 1 over x minus 5 equal 10 over x minus 5, x plus 5. Well, I can add the left side of this equation together. If I multiply this by x minus 5 over x minus 5 and multiply the next term, if I multiply that next term by x plus 5 over x plus 5, then I'll have a common denominator. So I will have, if I do that, x minus 5 plus x plus 5 over x plus 5, x minus 5 equal 10 over x minus 5, x plus 5. So this turns into 2x over x minus 5, x plus 5 equal 10 over x minus 5, x plus 5. So I've got the same denominator. So the only way this can be true, that 2x over x minus 5, x plus 5 equal 10 over x minus 5, x plus 5, the only way that works is if 2x is equal to 10 or x is equal to 5. So let's go back. What are my exclusions? X cannot be plus or minus 5. What is my solution? X equal 5, and that does not work. So that means there is no solution to this problem. Let us look at the next one. Here I have in the form of fraction over fraction. I can just cross multiply. So 3 times x plus 2 equal 5 times x plus 1. My exclusions are x cannot be -1 or -2. So this is what, 3x plus 6 equal 5x plus 5. If I subtract 5 from both sides, then I get 3x plus 1 equal 5x. Subtract 3x from both sides, 1 is equal to 2x. Therefore, x is equal to 1/2. Okay. So x is equal to 1/2 in this problem. Number 3, another rational equation. If I look at the right side, I need to combine those so I can see what the expression is. My exclusions, x cannot be equal to -1 or 0. So this turns into 5 over x plus 1 is equal to 8 over x minus 1 times x over x. That will give me the common denominator on the left side. So I will have 5 over x plus 1 equal 8 minus x over x. Now I've got fraction over fraction. When I multiply by the common denominator, which is x times x plus 1, that turns into the same thing as cross multiplying. So this becomes 5x equal 8 minus x times x plus 1. So this is 5x equal 8x plus 8 minus x squared minus x. So what I like to do, I like to have a positive x squared. I'm going to move everything to the left side. So I'm going to have x squared, and then, so 7, this is on the right side, I see 7x. If I move that to the other side, it's minus 7x. 5 minus 7 is 2. And that should be what I get. Let me double check. When I move the x squared to the left side, it becomes positive. On the right side, I've got 7x. When I move it to the left, it becomes negative 7x. 5 minus 7 is negative 2. That positive 8, when I move to the left, is a negative 8. Now I'm looking for two numbers that multiply to give me negative 8. So numbers that multiply to give you negative 8 and add to give you negative 2. Those numbers are 2 and 4 with a negative with a 4. So this turns into x minus 4, x plus 2 equals 0. Therefore, my solutions are x equal 4 and negative 2, and neither of those violates my exclusion. So those would be the appropriate answers. Next equation, solving here, I've got the form fraction, equal fraction, so I can cross multiply, and I get x squared equal 8 times x minus 2, which means x squared equal 8x minus 16, x squared minus 8x plus 16 equals 0. Are there two numbers that multiply to give you a 16 and add to give you a negative 8? That looks like a negative 4 and a negative 4 will do that. So this is x minus 4 times x minus 4. The exclusions, x cannot be equal to 0. My proposed solution is x equal 4, and that works out fine. Now we're moving into problems that were on the first quiz, rational expressions, performing this operation. One of the keys here, wherever you see something that can be factored, you must factor that. So this is negative 3x minus 7 over, if I look at the next term, that trinomial multiplies to 2 and adds to 3, that's 2 and 1. So that's x plus 2, x plus 1, plus 4 over x plus 1. My common denominator is going to be x plus 1, x plus 2. So that second term needs to be multiplied by x plus 2 over x plus 2. And when I combine all of that, I'm going to get negative 3x minus 7 plus 4 times x plus 2 over x plus 1, x plus 2. So that gives me negative 3x minus 7 plus 4x plus 8. All of that over x plus 1, x plus 2. So 4x minus 3x, that is x. 8 minus 7 is 1. This is x plus 1 over x plus 1, x plus 2. X plus 1 divided by x plus 1 is 1. So this answer is simply 1 over x plus 2. What are my exclusions? If I go back to my original problem, so if you look at this original here, what are the exclusions? X cannot be equal to negative 2 or negative 1. What is the solution here? 1 over x plus 2. Next one, perform an operation which is subtraction and simplify. Key here again, factor wherever you can. Looking at that first term, 2x plus 2 is the same as 2 times x plus 1. X squared minus 4x minus 5. Numbers that multiply to negative 5 and add to negative 4, that's a negative 5 and a positive 1. So this is x minus 5, x plus 1, minus x over, this is 3 times x minus 5. Now, factor wherever you can, simplify wherever you can. X plus 1 divided by x plus 1, that is 1. So this problem turns into 2 over x minus 5 minus x times 3, x minus 5. Common denominator is going to be 3 times x minus 5. So I need to multiply this first fraction by 3 over 3. And when I do that, I end up with 6 over x minus 5 times 3 minus x over 3, x minus 5. So this turns into 6 minus x over 3, x minus 5. So what are the exclusions? X cannot be equal to 5 or negative 1. And the final solution here was 6 minus x over 3, x minus 5. Number 7. Okay, again, the key is factoring wherever you can. Numbers that multiply to give you a negative 28 and add to give you a negative 3. That's probably going to be a 7 and a 4, with the 7 being negative. Those multiply to negative 28 and they add to negative 3. So this is x minus 7 over x plus 4. And then I see x squared minus 16. That is x minus 4 times x plus 4. What are my exclusions? X, they didn't ask that here. They asked that in a different form. Let me just write it here. My exclusions, x cannot be 4 or negative 4. Now, in simplifying this, x plus 4 over x plus 4 is 1. So this expression turns into x minus 7 over x minus 4. Any exclusion that is in your final answer is a vertical asymptote. So at x equals 4, that will be a vertical asymptote. Any exclusion that was simplified in the course of working this problem remains to be a hole in the graph, and that is x equal negative 4. Number 8, I'm doing a multiplication. And again, key to everything, simplify wherever you can. X to the 4th minus 16. So remember, x to the 4th minus 16. That's the difference of squares. X squared minus 4, x squared plus 4. Well, x squared minus 4, that's still the difference of squares. That's x minus 2, x plus 2, And I have no formula, I never will, for the sum of squares. That's all that we can do with that. So in simplifying this, I get that first term is going to be x minus 2, x plus 2, x squared plus 4, and then the denominator for that. Are there numbers that multiply to 4 and add to 4? Well, that's 2 and 2. So that's x plus 2, x plus 2, times x plus 4 over x minus 4. Okay? Remember, in canceling, it's about, once you're in fully factored form, any factor over itself gives you 1. So in this case, I see x plus 2 divided by x plus 2, and that is all, okay? There's nothing else that cancels here. So this remains, my final answer is x minus 2, x squared plus 4, times x plus 4, all of that divided by x plus 2, x minus 4, okay? So not really much simplifies in that one, but that is all we can do for this case. Let's look at the next one. Number 9, performing an operation. This is division. Key with division, we are going to change this to multiplication. This one's pretty cool. Someone has factored this for you, okay? So this is x plus 3 times x minus 2 divided by x over x minus 1. Change that to multiplication, times x over x plus 3. And now x plus 3 divided by x plus 3 is 1. X divided by x is 1. This turns into x minus 2 over x minus 1. Number 10, I have a complex fraction. So I've got to perform the operation in the numerator and the denominator and see how it simplifies from there. So I have x over 3 minus 6. Common denominator is going to be 3. So I multiply that by 3 over 3. All of that divided by 10 plus 4 over x. Common denominator here will be x. So this term has to be multiplied by x over x. When I do that operation, I'm going to have x minus 18 over 3 divided by, and you're going to have 10x plus 4. All of that divided by x. Now I have fraction over fraction. Turn this division into a multiplication. So this is x minus 18 over 3 times x over 10x plus 4. And so this is just x times x minus 18 over 3 times 10x plus 4. The only other thing you can do for factoring is that 10x plus 4, there's a 2 in common, so I could factor out a 2. So x times x minus 18 over 6 times, when I factor out the 2, I'm going to be left with 5x plus 2. Okay, and that is it. That as far as that one can go. Number 11 is the last one here. Again, complex fraction. You want to factor wherever you can, get common denominators. So immediately I see that this one can factor. So you're going to have 1 on the denominator, 1 over x plus 2 over x plus 1. All of that divided by, and this is 3x. I can factor x squared plus x as x times x plus 1. So in the numerator, the common denominator is going to be x times x plus 1. So I have to multiply this fraction by 1 in the form of x plus 1 over x plus 1. Multiply this by x over x. And I end up with x plus 1 over x, x plus 1 plus 2x over x plus 1 divided by 3x over x times x plus 1. So when I add all of this together, I get 3x plus 1 over x plus 1 divided by 3x over x plus 1. I can turn this division into a multiplication. So this is 3x plus 1 over x plus 1 times x plus 1 divided by 3x. X over x is 1. X plus 1 over x plus 1 is 1. This answer is 3x plus 1 over 3x. If you want to lose points, you could cancel those 3x's, but that would be wrong. You cannot. 3x plus 1 divided by 3x, those are not identical. So this is your final answer, 3x plus 1 over 3x. The only other thing you could do is you could break this up. Like I said, this is a good final answer. The other way of thinking of this is 3x over 3x plus 1 over 3x. So that is 1 plus 1 over 3x. So either of those would be acceptable final answers.